Hello everyone, welcome back. So in this video, we are going to look at today's LeetCode daily challenge, and the name of the problem is range sum of binary search key. So in this problem, we will be given the root of a binary search tree along with two integers low and high, and we need to return the sum of all the node values which lie in the range low and high inclusively. So this is the problem statement. So in order to understand the approach, we are going to consider this test case. So this is the example test case which we are going to consider. Before discussing the approach, we must keep this in mind that in a binary search tree, all the parent nodes have value greater than all the nodes in its left subtree, and all the parent nodes also have value less than all the nodes in its right subtree. So we must keep this in mind. Now, in order to solve this problem, we will be using recursion. So in the beginning, we are going to make a recursive call starting from the root of this binary search tree. So bringing the value of the root node is 10. So we are going to check if the given node is not equals to null, and if the value of this node lies in the range low and high inclusively. So yes, 10 lies in between 7 and 15. It means that we must add this value in our sum. So we will be adding 10. Then after adding 10, we will be making so in binary search tree is a binary tree, and in binary tree each node has value at most 2 children. So firstly, we are going to make function call to its left subtree. So on doing so, we'll come to this node first, and the value of this node is 5. So we are going to check, as the node is not equals to none, we are going to check, and we'll find that 5 does not lie in this range, and it is less than the low variable. So we are not going to add this in our sum, and also we'll be using the property of binary search tree. As this particular node is having value less than the low, it means that all the nodes in its left subtree will also have value less than this low. So it's of no use if we explore it. So exploring the left subtree of this node is of no use. So we will not make function call to its left subtree, but we will explore its right subtree, because it might be possible that in the right subtree we find nodes which lie in the given range. So next we are going to come at this node. So the value of this node is 7, and as we can see that it does lie in the given range. So we are going to add 7 in our sum. So 7 gets added. So after this, again, as we did before, we are going to make a function call to its left subtree. Then we are going to make a function call to its right subtree. So firstly, we will make a function call to its left subtree, and we'll find that the left subtree is null. So whenever a particular node is null, we are going to simply return 0. So we'll come back to this node, and after left subtree, we'll explore the right subtree, and right subtree of this node is also null, so we'll return 0. And then we are going to return back to node 5, as we have explored the right subtree of node 5, and there was no need to explore the left subtree. It means that we are done with this node as well. So we return to node 10. Now coming back to node 10, we have already explored the nodes in its left subtree. Now we are going to make a function call to its right subtree. Now we come to this node, and we check value of this node is 15, and it does lie in the given range. So we are going to add 15 also in our sum, and then we are going to make a function call to its left subtree. As the left subtree is null, we are going to return 0. Now after the left subtree, we will make a function call to its right subtree, and the value of the right subtree, we'll make a function call to its right subtree and we'll come to this node. So the value of this node is 18, and we can see that 18 does not lie in this range. So again, we are going to remember the property of binary search tree. If a particular node value is greater than high, then it means that all the nodes in its right subtree will also contain values greater than high. So it's of no use, and hence we are only going to make a function call to its left subtree and not to its right subtree. So when we make function call to its left subtree, we'll find that left subtree is null, and hence we are going to return 0. And we don't have to make a function call to its right subtree, hence we are going to return back to node 15. And as we have explored the right subtree also of node 15, it means we are done with this node, and hence we are going to return back to node 10. So we have explored the right subtree of node 10 as well, and here we are done with our process, and the answer will be the sum of all the values, and it will be 10 plus 7 plus 15, which gives us 32. So 32 will be the answer which we will get from our function, and as you can see, 32 is the right answer. So this was our simple recursive solution to solve this problem. Now let us look at the code. So in the solution here, I have written a DFS recursive function, and we are going to start our DFS starting from the root node, and whatever answer we will get, we are going to return that answer. Okay. Now in our DFS function, we will be passing our root node, and firstly we will check if the root node is not equals to null. It means that we are first going to check if the value of this node is less than the low variable. Then it means that all the nodes in the left subtree of that node will also have value less than the low variable. Hence we are only going to make a function call to its right subtree, and here we are doing the same. And if the value of the root node is greater than the high variable, it means that all the nodes in the right subtree will also have value greater than the high variable. Hence we are only going to make a function call to its left subtree. If both these conditions are false, it means that the value of the node lies between the given range, and hence we are going to add that value, and then we are going to make a function call to the left subtree, and after that we are going to make a function call to the right subtree, and we are going to return this. So this entire process is the recursion, and if a particular root node is equals to null, then we are going to return 0 in that case. So this is our DFS recursive function, and if I submit this code, then so as you can see, it got accepted. So this was it for this video. Thank you and have a nice day.